Hello everyone, this is Dr. Saida Fallafini from Cal Poly Pomona. In this presentation, I'm going to talk about system test, evaluation, and validation in system lifecycle. So test, evaluation, and validation is not a specific phase in the system lifecycle, but they are a set of actions that are performed throughout the system lifecycle, starting from conceptual design phase all the way to disposal phase. So tests and evaluations are very important for the success of every project. There have been various examples of different types of projects that have failed due to lack of proper test and evaluation actions. For example, the joint US-Russian Skipper mission failed in 1996 only because the solar panels were connected backwards and none of the test and evaluation operations were able to detect this problem. So as we go through the test and evaluation operations, our main goal is to make sure that we have met the requirements of the customer. So at the end of the day, the system or product that we are delivering to the customer has been able to meet all the requirements of the customers. So for every requirement that we have in the system, we have to be able to develop a plan to test and evaluate if this requirement has been met in the system that we have designed and delivered at the end of the day. So as we plan for test and evaluation, we develop a document that is called Test and Evaluation Master Plan. In this document, we provide detail on how every requirement of the system is going to be tested, what procedures will be performed, who is in charge of performing those tests, and what we will do with the results. The early version of this document is developed in conceptual design, but as we go through preliminary and detailed design, more detail is added to this document. So test and evaluation start at the early in the life cycle of the systems. However, as we go through preliminary and detailed design and as we develop prototype of the system, tests and evaluations become more relevant, and they even become more important as we prepare to get into the production phase. So in our textbook, 5 major milestones have been defined in the life cycle of the project for performing different type of tests. So in the next couple of slides, we are going to go into the detail of each type of test and when they are performed in the life cycle. So the first set of tests are called analytical evaluations. They are usually performed in the early phases of the life cycle of the system, mainly in conceptual design and preliminary design phases. And they are usually include a set of analytical methods, mathematical models, and simulations to be able to test if the design that has been developed will meet the requirements of the system. As an example, imagine you have been asked to design a production line, and so you have a set of machines in mind that you want to install, the order of the machines that should be installed, and the number of laborers that should be hired. So you can use a set of mathematical and simulation models to mimic this production line and make sure that this setup can meet the production rate that you have in mind before you proceed with the rest of the design process. So the next type of testing is called type 1 testing. Type 1 testing is usually performed early in the detailed design phase. So as we develop the components of the system to assemble them and make the whole system, we usually perform type 1 testing on each component to make sure that they meet the system requirements before we proceed with the rest of the assembly process. Type 2 testing is the next set of tests that are performed usually toward the end of the detailed design phase. So toward the end of the detailed design phase is where we develop the prototype of the system. Usually at this stage, we perform some important tests on the prototype of the system. For example, if we are designing an airplane, we put airplane under the test in a wind tunnel. If we are designing a car, we usually perform various type of tests, for example, safety tests on the car. So these type of tests usually are performed toward the end of the detailed design phase on the prototype of the system. The next set of tests are called type 3 testing. These set of tests are also performed toward the end of the detailed design phase on the prototype of the system. However, at this stage, we usually perform the test in real world situations. For example, if we are designing an airplane, we take the prototype that we have for the airplane for actual fly under real world conditions, different environmental conditions. If you are designing a car, we take the car for a ride in real world conditions. And so this test is very, very important, because after type 3 testing, if the prototype is performing properly in the real world conditions, we give the green light to the production phase. Finally, type 4 testing is performed when the product has been delivered to the customer and is being used. This type of test is very meaningful, especially in software products, because it has happened probably to you that a lot of the times as you are installing and using different type of softwares, you may see some bugs or some problems. So usually these problems that customers are facing are reported to the manufacturers, and they usually develop an update for the software, and they release those updates to the customers. So after customers install those updates, these problems that they have observed as they are using the product are being addressed. So these are the type of issues that manufacturers have not been able to detect during the design phase. So now that a product is being used by the customer, they still are performing this type of test to be able to detect the issues that customers may face. Now that we know different type of tests, in our test and evaluation master plan, we are going to specify all the requirements of the system, and for each requirement we are going to specify what type of test should be performed to be able to make sure that requirement has been met. For example, this specific requirement is going to be evaluated using type 1 testing. This specific requirement is going to be evaluated using type 4 testing, and so forth. So more specifically, in test and evaluation master plan, we are going to specify specific requirements or items or components that should be tested. We are going to specify the type of test that should be performed and the procedure that we are going to perform to run the test. We are going to specify if we need any specific site or environment to perform the test. We will specify if we need any specific skill sets or any specific personnel to perform the test, or if we need to provide any training to the personnel that will perform the test. We specify if we need any specific facility or logistic or support for performing the test, or if we need any specific resources. And after performing the test, we usually develop a report in which we are going to specify the goal of the test, what was the purpose of the test, what are the conditions under which we performed the test, what are the actions or operations we performed, the changes we made in the product as we were running the test, the data that we used to perform the test, and finally, what are the results after performing the test operation, and conclusions and recommendations. If the test that we perform concluded that the component meets the requirements, or no, we observe some failure, and as a result we have to go back and correct the design. So as we plan for different actions in the system lifecycle, we also have to plan for actions related to test, verification, and validation. And usually some of the system engineering process models make it easier to plan for test operations, such as V model. For example, in the V model, we start by understanding customer requirements, and as we go through the design, we usually define the architecture of the system by specifying different modules in the system, and then we go into developing those modules, testing them, integrating them, and then testing them again to make sure that the final product is going to meet the customer requirements. So V model is one of those process models that make it a little easier to incorporate test and verifications operations in the life cycle of the system. As we're performing the test and verification and validation operations, a lot of data will be collected in the system, and our goal by collecting this data is to answer these ultimate questions, that if we have been able to meet the requirements of the customer, and also if this system that we are designing is part of a system of system, will this system be able to work with the rest of the components, and is it going to be integrated properly with the rest of the components. So as we plan for tests and validations to collect the data, we also need to have specific procedures to make sure that for any kind of failure that we observe, we can take proper actions. So we have to be able to collect the data on the failures that we observe and to report those data to proper managers. And those managers, usually based on some change management plans, are going to take the right actions to see now what type of change should be performed in the design, or what components should be changed so that we can address the failure that we have observed during the test operations.